Okay, so this is the video I recorded the other day and I realised I made a mistake, or more to the point, Miss Boss told me that I made a mistake when she checked it out. So I'm just going to run through it again and hopefully fix up my mistake. So as I mentioned in the first video, we're working with polynomials and we've got function notation here. So how do I know this is a polynomial? Well, what we've been discussing is if we put the p there for a polynomial, and then we know it is a function because it's got this notation where we say p of x, and this is basically just telling me that the variable is x. And that means if I know that the variable is x, that means that these other two letters in here, a and b, they are constant values. They have to be a number that we can work out. When I write the expression as p negative 1 in the second brackets here, that's telling me that when I substitute in negative 1, it'll be equal to the same value as when I substitute in 2, and the value that it equals is 0. So that's what that notation is telling me. When I substitute in negative 1 and when I substitute in 2, then the answer will actually give me 0. So let's actually work with that in our expression. Let's start by substituting in, sub in x equals negative 1. Alright, so when I do that, I end up with p of negative 1 will equal 3 times negative 1 to the power of 6 minus 5 times negative 1 to the power of 3 plus a times negative 1 squared plus b times negative 1 plus 10. Oops. Plus 10. And when I do this, I know that the answer is equal to 0. Now that looks like a pretty long expression, and my hint from my previous lessons has been at this stage, at the substitution stage, write in the time signs and put the number that you're substituting into the brackets. So I'm going to simplify this now. Now a negative to the power of an even number will always become a positive. So negative 1 to the power of 6 is just 1, and 3 times 1 is just 3. A negative to an odd power is going to be a negative number. So negative 1 to the power of 3 is negative 1. And then negative 1 times negative 5 is positive 5. Negative 1 squared, so again a negative to an even power becomes a positive number. So negative 1 squared is positive 1. Positive 1 times a is 1a, and I don't need to write the 1 in there. And then negative 1 times b is negative b plus 10, and it all equals 0. Now, as a general habit with my rules in maths, I wouldn't normally write two equal signs, so I wouldn't normally have an equals at the end and the start of the expression. So I'm just going to change this to put a little arrow on there, and this means when we're writing, this means that it follows. So I read that arrow as it follows. Now that's not important, but you'll see that sometimes in the work of different math teachers and different examples, and that's what it's talking about. Okay, so I'll keep that going. So it now follows that a minus b equals negative 18. Now the way I got the negative 18 is I added the 3, the 5 and the 10, which is positive 18, and then I moved them to the other side of the equal sign by subtracting 18 from both sides of the expression. All right, and then this gives me my first equation that I can work with. So now let's sub in x equals 2. And that looks like this. So I'm going to replace all of the x's with 2's, and then that gives me 3 times 2 to the power of 6 minus 5 times 2 to the power of 3 plus a times 2 to the power of 2, and that's where I made my mistake last time. I didn't have the power of 2 there. B times 2 plus 10, and again it equals 0. So it now follows, now 2 to the power of 6, so that's 2, 4, 8, 16, 32, 64. So that's 3 times 64. 2 to the power of 3 is 8, so minus 5 times 8, which is 40. 2 squared is 4, so I get 4a plus 2b plus 10. And I don't know why I put a 10 over here before. That shouldn't be a 10. That should have been a 0. And that all equals 0. So this expression equals 0. So a bit of tidying up here. 3 times 64. Right, so I need to do 3 times 60 is 180. 3 times 4, so that's 192 minus 40 plus 4a plus 2b plus 10 equals 0. Tidy this up. 192 plus 10 is 202. Subtract 40 is 162. So 162 plus 4a plus 2b equals 0. And these numbers that we're working with, that would be perfectly fair for you to get on a calculator-free exam. Now I'm actually going to divide everything by 2 just to make this a little bit easier. So I'm going to divide everything by 2. And I'm allowed to do this as long as I do the same to both sides of my equation. Still equals 0. And then final thing, I'm going to move that 81 to the other side of the expression. It becomes minus 81. And this is my second equation. So what I've just set up is simultaneous equations. I have a first equation with an a and a b in it, and a second equation with an a and a b in it. And to put these two together, I would actually use the elimination process. So I'm going to do equation 2 plus equation 1. And when I do that, I get 2a plus a, which is 3a, b plus negative b, which is 0b, and then negative 81 plus negative 18, which is negative 99. Now I don't need to write the 0b, so I can just say that 3a equals negative 99, and then a equals negative 33. Right, so I've got my value for A. I'm going to find out the value for B, and I'm going to sub this into equation 1. So if I put that back into equation 1, I end up with negative 33 minus B equals negative 18. So negative 33 plus 18 equals B. I've just rearranged here. So I'll just show you, I've put the B on that side and made it a plus B, and I've put the negative 18 on that side and make it a plus 18. And then final part, negative 33 plus 18 is equal to negative 15. So therefore, A equals negative 33 and B equals negative 15. And that's my final answer, this time without